Hello and welcome to the video. In this video we are going to talk through graphing inequalities and shading regions based on those inequalities. In order to do that we need to have a little recap of some straight line graphs. So to start with we're going to look at four basic linear graphs. To start with we're going to look at y equals 2. If we wanted to graph y equals 2, it would look like this. We have a horizontal line which cuts through the 2 on the y-axis. So anytime we have y equals something, we're always dealing with a horizontal line, and the something is where it cuts the y-axis. If we were to think of this in the form y equals mx plus c, the m before the x depicts the gradient. And therefore there is no gradient in a line that looks like this, which is why we have a horizontal line. There is no slope on this line. So this could be y equals 0x plus 2, but we just write it as y equals 2. So anytime you have a y equals, you're expecting a horizontal line cutting through the number that y equals. So if I had a line going straight across here, I would call that y equals -1 because it would have crossed at -1. Okay, if we look at this, x equals -3. So if I wanted to graph x equals -3, it would look like this. So this time we're dealing with a vertical line. The vertical line x equals -3. This time it cuts the x-axis at -3. So this time we are dealing with a vertical line. Whatever the value equals to x, then that is where it should cut the x-axis. Because if we pick any point on this line, any of these coordinates, the x-coordinate is always -3, which is why we end up with a vertical line. Very similar thing happens back on this graph. If we were to pick any point, any coordinate on this line, the y value, the y coordinate would always be 2. So when you have y equals, you're expecting a horizontal line. When you have x equals, you're expecting a vertical line. Okay, we're going to have a look at two more straight line graphs, two more linear graphs, starting with y equals x. So if you were asked to graph y equals x, which is a very common question when we start talking about graphing inequalities, your graph would look like this. Y equals x always creates a diagonal line going through the origin 0, 0. If I was to pick any point on the line, 4, 4, 3, 3, 2, 2, 1, 1, 0, 0, or even down here, -3, -3, -2, -2, every coordinate is when the y coordinate equals the x coordinate, which is why we end up having a diagonal line which goes through the origin. Okay, so now we get on to a little bit more complex straight lines. So remember what we've talked about on the previous slide. Y equals mx plus c. When m, the number in front of the x, is your gradient, and c, your number at the end here, is your y-intercept. So we could go ahead and draw any graph once we're given it in the form y equals mx plus c. For this graph, it would look like this. I know it's in the form y equals mx plus c, so I know my y-intercept is 1, which is why I have the graph crossing at 1 here. And my gradient is 2, which means if I choose a point on the line, for every 1 square along, I would have went 2 squares up. For every 1 square along, I would have went 2 squares up. which means this line is the graphical representation of y equals 2x plus 1. We could also do the same thinking about coordinates. If I was to choose this coordinate, so that is when x is 1, and if I substituted that into this little bit of algebra, 1 times 2 is 2, plus a 1 is 3, so then if I look across at my y coordinate, it would of course be 3. Okay, so that was just a recap of 4 basic linear graphs, straight line graphs that we should already understand. Now let's have a look at using them to graph some inequalities. Okay, so now we're going to use that knowledge of linear graphs, of straight line graphs, to identify some regions by graphing inequalities. In this question, we need to shade in the unwanted area and then label the required region R. The wording of this question is very important because depending on the exam question, depending on the task, sometimes you'll need to shade in the required region, sometimes you'll need to shade in the unrequired region. In this question, we're shading in the area we do not want, and we are labeling the area we want with an R. Okay, let's have a look at question 1. Show by shading on the grid the region defined by x is less than 3 and label the region you want as R. So I'm going to draw the graph of x equals 3. We know from the previous few slides that it should be a vertical line going through the point 3 on the x-axis. So any point on this line, the coordinate of x would be 3. Notice that I've used a red dotted line. That is not by accident. We use a red dotted line when graphing inequalities to represent this inequality sign here, less than, and it does not have the line underneath. So a dotted line is associated with an inequality sign that is just less than or greater than. If the inequality read as less than or equal to, so it had the little line underneath, then we would use a full line with no breaks. So it would not be a dotted line. So I've used a dotted line because this inequality sign does not have the little line underneath it. Now I need to go ahead and answer my question. I want to shade in the unwanted area and then label the required area as R. So I want all the values when x is less than 3. So that's this part of the graph. Anything here, anything on this side of the red dotted line, my x value would be less than 3. So this is the area I want, which means I'm going to go ahead and shade in this area as my unwanted area, and I'm going to label my required area as R. And on to question 2. So this time we're asked to show by shading on the grid the region defined by y is less than x, and we're going to label the region R. Okay, so we need to shade in our unwanted region and label the required region as R. To start with, I'm going to draw in the linear graph y equals x. We know from the previous few slides that y equals x is a diagonal line which goes through the origin 0, 0. So now I need to decide if my required region is this side or this side. So I'm going to pick a coordinate. If I pick this coordinate here, this is the coordinate when x is -1 and y is 2. So that does not satisfy this inequality, because x is less than the y value. If I take this coordinate over here, this is when x is 4 and y is 1. So this time y is less than x. Let's take another coordinate. If I take this one here, the x coordinate is 3 and the y coordinate is -1. So -1 is less than 3. So this is my required side. This is the side of the inequality that I am interested in. So I'm going to shade this side just to blank it out. That is my unwanted region. And my wanted region is labeled R. Notice again that I've used a red dotted line because I'm dealing with y is less than x. It does not say y is less than and equal to x. If it did say that, I'd be using a full red line with no breaks and no dots. Okay, we'll look at question 3 and 4. Remember, you do have the ability to pause the video and have a go at these questions yourself if you wish. Question 3. Show by shading on the grid the region defined by -3 is less than or equal to y, which is less than 2. Okay, so this time I'm going to draw on two separate graphs. I'm going to start with this part of the inequality here. Y is less than 2. So I'm going to draw on the graph of y equals 2, which I know from my earlier slides is a horizontal line going through the number 2. I'm also going to draw on the graph of y equals -3. But this time the inequality sign is equal to as well. So I'm going to use a full red line, not just a dotted red line. So I'm going to draw in a full red line at -3, like so. So we can see from here I've now got the graph of y equaling -3 with a full red line because it's equal to, and also the graph of y equals 2 with a dotted line because it's not equal to. So now I want the values of y which are greater than or equal to -3, but also less than 2. So basically, I want this area here. I want this area within my two lines. This is the area that satisfies my inequality. So this is going to be my region labeled R, which means I want to shade in this unwanted area, and I'm going to shade in this unwanted area. So my final solution is going to look something like that. So I've identified my required region and labeled it R, and my unwanted regions have been shaded out because they are not satisfying the inequality. And let's move on to question 4, where we're being asked to show by shading on the grid the region defined by y is greater than or equal to 0.5x minus 1. So what we have here is a linear graph in the form of y equals mx plus c. M being the gradient, 0.5, and c being the y-intercept, -1. So we're going to go ahead and draw the graph of y equals 1/2 x minus 1. And we know from our knowledge of y equals mx plus c that the graph is going to cross the y-axis at -1, and for every 1 square along, it's going to go 1/2 a square up. So our linear graph is going to look something like this. So you can see that the linear graph I've just drawn crosses the y-axis at -1, which corresponds to this c value, this y-intercept of -1. And if I was to pick a point on the graph and go 1 square along, I would go 1/2 a square up, corresponding to a gradient of 1/2. Notice that I've used a full line again. I'm not using a dotted line. It's not a broken line because, again, we are dealing with the inequality of greater than or equal to. So the fact that that little line is under the inequality sign means that I want a full line, not a dotted line. So now I need to think of the region that I am interested in. So the wanted region and the unwanted region. The unwanted region I'm going to shade in because that's no longer wanted, and the required region is going to be labeled R. If I pick a point, if I pick a coordinate, let's pick this coordinate here. So this is the coordinate when x is 6 and y is 1. So if I substitute x is 6 into this little bit of algebra here, a half times 6 is 3, take away 1 is 2. So what that's telling me now is my y value of 1 is greater than or equal to 2. So that was the result of substituting my 6 into this bit of algebra. And of course, that is not correct. So this coordinate does not satisfy this inequality. So therefore, this area underneath this linear graph here is my unwanted region, which I'm going to shade in. And my required region is the region up here, which I'm going to label R. So my completed answer looks like this. A nice straight line, and I was able to draw that by using my knowledge of y-intercept at -1. There we go. And a gradient of a half, one along, a half up. So I've drawn in a nice straight linear graph. It's a full line, and that is because of the inequality sign having this little line underneath it, greater than or equal to. Then I've chosen a coordinate and worked out if that coordinate satisfies the inequality or not. All the coordinates under here do not satisfy the inequality, so they're shaded in. And the coordinates in this region do satisfy the inequality, which is why I've labeled them R. Okay, so here's a task for you to have a go at. There is 6 shaded regions on the screen in front of you. However, the question is asking you to write down the inequality that defines the unshaded region. So it is the white section of each graph, the unshaded region that I'm interested in. For each graph, could you write down the inequality that defines the unshaded region? Could you pause the video now and have a go at these 6 questions? Okay, welcome back. Let's have a little look at my solutions. Okay, here we go. So we have, for the first one, x is greater than or equal to -2. We know it's the graph of x equals -2 because it crosses the x-axis at -2. Every x value on this line is -2, and it is greater than or equal to because it is a thick line, it is not a dotted line. And we want when x is greater than or equal to -2, so we want this side. This is the side we're talking about, the unshaded region. For the second question, we've got a dotted line because our inequality sign is different. It does not have the line underneath. We want all the values when y is less than 1. So this is the area we're interested in. We shade out this area. This is our required region, y being less than 1. This time, the inequality is enclosed by 2 lines. We've got when x is greater than -3, dotted line through -3, and when x is less than or equal to 2, so this time we've got a nice full line through the number 2. The white region is the region we require, which is where this inequality comes from. This time we're dealing with y equals x. It's a diagonal that goes through the origin. It's not a dotted line because we've got a line underneath our inequality sign. Y is greater than or equal to x, and we're looking for the values in the white area here, which is y. These are all these values. If we take a coordinate, the y value would be greater than or equal to x. The area that's shaded, they would not satisfy this inequality. This time we've drawn in the graph of y equals 2x, so there's no y-intercept, so it crosses at the origin, and every one along we go 2 up because it has a gradient of 2. We want all the values when y is less than or equal to 2x, they would all land in this white area here. Not a dotted line because the inequality sign has a line underneath it. So finally, we are asked for this graph here. You may have used this version because it's in the form y equals mx plus c, or you may have rearranged it slightly as well. So if we're thinking of the graph of this dotted line, it would be y equals minus x plus 2, because it crosses the axes at 2 and it has a gradient of negative 1. Every one square along, it goes 1 down. 1 along, 1 down. And the reason we are using y is less than minus x plus 2 is because every coordinate in this white area would satisfy this inequality. Dotted line used this time because the inequality sign is just less than. Very well done if you were able to work out all 6 of those inequalities. For the final 4 questions, question 5, 6, 7, and 8, we get a lot more complex. I'm going to talk through each question briefly, but you have the ability to pause the video at any point. So if you really want to have a go at these questions yourself and challenge yourself, then you can do that as well. Okay, let's look through question 5. Show by shading on the grid the region defined by minus 2 is less than y, which is less than or equal to 3, and also minus 3 is less than or equal to x, which is less than 5. So if I was going to draw this graphically and label my region, it would look something like this. So we have for our y graphs, for our y lines, we have y equals 3 here, and it's a full line. And we have y equals minus 2 here, and it is a dotted line, because that depends on the inequality sign in the question. At the same time, we also have x equals minus 3, which is a full line, and x equals 5, which is a dotted line. So now we want all the values where the y coordinate is greater than minus 2 but less than 3, and the x coordinate is greater than minus 3 but less than 5. So any point in here, any point which I have left white, would be our required region, which is why I've labeled it R. The unwanted regions are of course shaded in to show that they're excluded, and the required region, the region that satisfies both of these inequalities, is labeled R. For question 6, we need to draw on the grid the lines x is greater than or equal to minus 3, so we know that's going to be a full line. Y is less than 2, we're going to have a dotted line, and y is greater than x, another dotted line. If we go ahead and add all 3 of those to our graph, it will look something like this. So here is x equals minus 3 with a full line. Here is y equals 2 with a dotted line, and here is y equals x also with a dotted line. So now we're looking for the region where the x coordinates are greater than or equal to minus 3, the y coordinates are always less than 2, and the y coordinate is always greater than the x coordinate. So it's this enclosed area here, which I've left white and I've labeled as R. The unwanted regions are shaded in because they're not included. My required region is labeled as R. Last 2 questions of the video. Again, you can pause the video at this point. We're looking at some complex questions here, and you can go ahead and have a go at the question yourself. For question 7, I'm going to draw the graph of x plus y is less than or equal to minus 1, which I may rearrange to be y is less than or equal to minus x minus 1 by subtracting x from both sides. Then I also want the line x is greater than or equal to minus 4, and also the horizontal line y is greater than or equal to minus 3. If I go ahead and draw all of those lines, here's my line for y equals negative 3, and it's a full line because of the inequality sign. Here's my line of x equals minus 4, again, it's a full line. And here is my linear graph of x plus y equals minus 1. I could have rearranged that to be y equals minus x minus 1. So I know it crosses at negative 1 and has a gradient of negative 1. Then I'm looking for the region that's enclosed by all three inequalities. The region that satisfies all three inequalities is this white region here. All my unwanted regions are shaded in to show that they're not included. They do not satisfy the inequality. Okay, last question. So we are going to draw three linear graphs. We're going to draw the graph of y equals x plus 3. We're going to draw the vertical graph of x equals minus 3. And then we're also going to draw the graph of 2y minus x is less than or equal to 4, or 2y minus x equals 4 for the basis of drawing it. So if I was to go ahead and draw the graphs, it would look like this. So we've got x equals minus 3 with a full line, dots not included for that one. Then we've also got the line here, which has a y-intercept of 3, so that is y equals x plus 3, gradient of 1, dotted line as well because of the inequality sign. And then we've also drawn this line here. We could have rearranged it to read y equals a half x plus 2. So that would be your plus 2 for your y-intercept, your half for your gradient, every one square across, you're going up a half. And the required region that satisfies all three of these inequalities is this tiny little unshaded region in here, which I've labeled R with an arrow. Everything that is unwanted is shaded in, and my required region is R, this little region here. Very well done if you were able to have a go at those last two very difficult, very challenging questions. But if you were able to give them a go, that is pretty much the extent that you would need to know approaching your exams. So very well done if you answered questions 7 and 8 correctly. And very well done for completing the lesson. Hopefully you've got a good understanding of graphing inequalities and shading regions.